Hello everyone and welcome back to the IGCSE Additional Mathematics 0606 course. Today we will be covering chapter 8, which is coordinate geometry of the circle. Let's get started. The first thing you should learn are the circle equations. So this is the number 1 is this, where x minus a whole squared plus y minus b whole squared is equal to r squared. So a comma b is the center and r represents the radius. So this can be a bit of a confusing point. R is the radius, not r squared. So usually this will be given as either like 25 represents the radius is 5 or 16 says that the radius is 4. And then if this is given as, let's say, x plus 3, then you take the x coordinate as negative 3 comma whatever the y is. So just remember that. And then the second form, this is actually basically this one but expanded. So as you can see here, if we work backwards, we come back to this form here. So this is basically just completing the square, which you learned in quadratics. And so as you can see here, so if we compare these two, you can see that minus g comma minus f will be the center, and then this will be r squared, the right hand side. So you just take the square root of that to get the radius. So obviously if you are given a question of this form, don't try and remember these, complete the square and then just use these ones because it's much simpler to remember this. Okay, now the second part is the intersection of a circle and a line. So there's three possibilities. The circle and the line don't intersect, in which case the discriminant is less than 0. The circle and the line intersect once, so we call this line to be a tangent to the circle at this point, and we say that the discriminant is equal to 0, and then they intersect twice, so the discriminant is greater than 0. You can, if you recall, this is actually similar to what we learned about the intersection of a quadratic curve and a line. So if you're given a circle equation and the equation of the line, what you do is you just substitute this y in here and then you expand this out and then you get the discriminant, right? So b is the coefficient of x, a is the coefficient of x squared, and then c is just the constant term. So just take the r squared to the other side, equate it to 0, find the discriminant, and yeah, you can get the point of intersection. Now, basically the number of points of intersection really. If you were to find the point of intersection, you would need some other information as well. Okay, now these are some basic circle theorems that you should know. If you have a tangent to the circle, then the tangent is always going to be perpendicular to the radius at that point. So if we say this is the center of the circle, this is the tangent, this is the foot of the perpendicular here, then this is a 90-degree angle. Just remember this. This is actually one of the most commonly used tactics to solve questions. Now this is something called a cyclic quadrilateral, where basically you have two tangents to the circle like this. They form, so these two, basically this length from this point to this point and this point to this point are the same. As you can see, it's indicated by these lines, and then these lengths, obviously because they're both radii, are also the same. And another thing, this angle alpha and this angle beta add up to 180 degrees. So that's also another property of cyclic quadrilaterals. Alright, now the last thing for this chapter are the intersections of circles. So again, there's three different conditions. They don't intersect, they intersect once, or this one is just completely inside it. So if we look here, you can see that the distance between the centers of these two circles is actually greater than both the radii combined, because as you can see, this distance is actually the two radii plus this extra distance between the circles. So that's the way to identify this condition. Now this condition, oh sorry, yeah, and then, oh sorry, there's four cases actually, my bad. The fourth one is where these two intersect twice. Now this one is where the distance is actually just equal to the sum of both radii, as you can see in the diagram. The third one, I kind of forgot this one, is where, so this is a bit complex actually, but as if you simplify this, you can see that R2 minus R1, which is essentially uh, this area here. Okay, wait. See, R2 covers this entire length and then R1 covers this entire length. So it's actually like, so this is the common area which is gone, and you just have, so basically R2 minus R1 is, so D, okay, I'll simplify this. D is greater than the difference of the two radii and less than the sum of the two radii for this case. Okay, now yeah, basically I would advise you for questions like this to actually draw the diagram and figure it out, because it's really simple to draw the diagram. I'll come to that part later. We'll do this example then. And then this one is where the circle is just inside the other one, so it's actually similar to this but just opposite. So it's actually the difference of the two radii, and D is less than that. So if we look at the question, it's obviously a lot of working to find the point of intersection, but really it is just you get both of the circles in an expanded form here like this. So this second circle is, I have just expanded it to this one. And then if you look here, so since we've equated both of them to 0, we can actually equate the two circle equations to each other. And you can see that in most cases x squared y squared cancel. So you're left with this equation of a straight line. Now this straight line you can input into either of the two equations. I would recommend you do it into this one because the y is actually separate here, so you don't have to expand the squared here. It's much simpler to do that just once. And then you find the value of x, you substitute back into this one, and you find the value of y. So let's, if we actually look at the, I'll draw a dot diagram here for you. So let's simplify it. So we have x squared, actually wait, go over here a little bit, x squared minus 16x plus y squared minus 10y plus 73 is equal to 0. X minus 4 whole squared minus 16 plus y minus 5 whole squared minus 25 plus 73 is equal to 0. So x minus 4 whole squared plus y minus 5 whole squared is equal to negative 73 plus 25 plus 16, which is what? Negative 32. Okay, should not be possible. Let's x squared plus y squared. Oh, it's my bad, my bad. I figured. Wait. Yeah. Okay, 8 now. Yeah, this will be 8. Okay, yeah, it's my mistake. Sorry. Yeah, 8 here, and then so this answer will be completely different. Yep. Okay, so what we have, 64 plus 25 minus 73 gives you 16. Okay, yeah. So if we are to draw, let's say two axes, you can see that this has a point at 8. Um, so this will be 8, let's say over here, comma 5. So here with the radius of 4. So 4 comma 5 over here, 8 comma 9, 12 comma 5, and 8 comma 1. So this is actually one circle. Okay, now we see here there's actually one point of intersection. So if we come back to our second equation, we have 10 and 6.5, and then 2.25 gives us 1.5. Okay, so 10 and 6.5 would approximately be here, and then 1.5. So this might look something like this, actually, with this being the one point of intersection. Me reconfirm that. I opened Desmos anyways, so we'll just check. 16x minus 10y plus 73 equal to 0. So as you can see, that's the circle. X minus 10 whole squared plus y minus 6.5 whole squared equal to 2.25. And yep, So you can see it's the same thing. So this is actually touching at one point. So it's this condition, except so it's a mix of these two actually, where this is inside it, but also touching it at one point really. So yeah, that's actually kind of an interesting question. So these are the conditions, but don't memorize the distance formulas. Actually go for drawing the diagram and then actually solving the problem. But yeah, that's about it for this video. If you want to suggest me any specific topics to focus on or any questions you would like me to do, you can just drop it down in the comments. Thank you for watching.